All right. So, again, on Friday, we developed points, coordinates, right, for angles on our unit circle. All right. And then we also found that when we did sine of a particular angle or cosine of a particular angle, they corresponded, they matched to the coordinates of the point at that angle. Okay, so for example, if you do the cosine of 30 degrees, that is equal to the x-coordinate of the point on your unit circle there, right? If you do sine of, let's say, 2 pi over 3, or 120 degrees here, sine corresponds to positive root 3 over 2, the y-coordinate of the point on your unit circle. Okay? So, given these x and y coordinates, we can find sine and cosine pretty easily on your unit circle. But what if we have other relationships or other trig ratios we want to find? Like, for example, tangent. Or what about like the reciprocal trig functions, like secant or cosecant or cotangent, right? How are we supposed to evaluate those, given that we only can find sine and cosine? Well, as it turns out, we only need to find sine and cosine, and once we know sine and cosine, we can find all the other information that we need. Or find any other trig ratio, I'll say. Okay? So I'll introduce you to tangent here. We'll do like a couple tangent problems, then I'll also show you how we're going to do like secant, cosecant, and cotangent. And then finally, I'll kind of give you like a big strategy overall for evaluating trig functions, because eventually we want to get to the point where we can just evaluate sine, cosine, tangent, cosecant, secant, or cotangent of any angle in that unit circle, and be able to do it with relative, speed and efficiency. Okay, so let's talk about this here. So we'll say the rest of the ratios. Okay, the rest of the ratios, the remaining ratios, right? So we'll say tangent, secant, cosecant, and cotangent. That's the 4 other ones we'll be looking at. So, first of all, for secant and cosecant, well, actually, I'll hold off on that. Let's just worry about tangent right now. We'll focus on tangent. Okay, here's the key concept we're going to use to help us to identify tangent. Okay, tangent is equal to the ratio of sine theta over the cosine of theta. So tangent of theta is equal to sine of theta over cosine of theta. So in other words, anytime you want to find tangent of an angle, you just do sine of that angle divided by cosine of that angle, and that'll give you tangent of the angle. So let's just do like a quick example here or two. So for example, the tangent of 30 degrees. Okay, and for our purposes here, I'm going to convert any degree measure into radian measure because that's going to be helpful, just again for our purposes of getting things down and feeling more comfortable with trig and stuff like that. 30 degrees is equal to what in terms of radians? Pi over 6. So equivalently, we could say tangent of pi over 6. That's going to equal then the sine of pi over 6 over the cosine of pi over 6. Okay. What is the sine of pi over 6? If you want to, you can look at your unit circles. What's the sine of pi over 6? 1/2. 1/2. What's the cosine of pi over 6? Root 3 over 2. Okay. But of course, this we could leave it here. I mean, technically this is the answer, but we should really try and simplify it because we do have fractions within fractions here. So instead of dividing by root 3 over 2, we can multiply by what? The reciprocal, right? 2 over root 3. And the 2's will cancel, right? They'll simplify out, and we're left with 1 over the square root of 3, or if we rationalize, root 3 over 3. Okay? So there's tangent of 30 degrees. Questions on any of that? And you won't be doing this every time for tangent, okay? You won't always have to convert it into sine divided by cosine. But I'm just showing you like one way to do it, and then I'll show you like a faster way to do it using reference triangles. So tangent of 45 degrees. 45 degrees is what in radians?
2
Pi over 4 in radians. No, yeah, right, exactly, yeah. Just asking to convert from the degrees to the radians there. And then we'll say, aha, that's then sine of pi over 4 over the cosine of pi over 4. Okay, and then what is sine of pi over 4?
1.
Well, just sine of pi over 4.
The root 2 over 2.
Root 2 over 2, and then so is cosine of pi over 4, also root 2 over 2. Okay, right? And so then what is root 2 over 2 divided by root 2 over 2?
1.
We're dividing something by itself. Yeah, so it's 1. So you just get 1. Okay, so on and so forth. Let me give you guys 2 to try here. I'm not going to do tangent of 60 degrees. I mean, you can do that. It's pretty easy. You know, just do sine of 60 divided by cosine of 60. But I do want to give you 2 here to try. So how about tangent of pi over 2 and tangent of 0? Okay, evaluate those. Tangent of pi over 2, tangent of 0. Okay, what will those be? Okay? Again, tangent of pi over 2, tangent of 0. Your best estimate there. Not estimate, exact. Okay. So, tangent of pi over 2 is? Does not exist or undefined. Does not exist or undefined because tangent, a sine of pi over 2 is 1, cosine of pi over 2 is 0, 1 over 0 undefined. Very good. Okay, how about tangent of 0? 0, very good. Okay. So there you go. Questions on any of that? Okay, so then what about secant? What about cosecant? What about cotangent? Well, we're going to use the fact that secant of theta is really 1 over what? Cosine. So in order to evaluate secant, just evaluate cosine at that angle and then reciprocate. Okay, do the reciprocal. Likewise with cosecant. Cosecant of theta is the reciprocal of sine. And so again, if you're going to evaluate cosecant of an angle, just find sine of that angle and then again do the reciprocal. And last but not least, cotangent of theta. That's reciprocal of what? 1 over tangent. Yep, exactly right. And again, if you want to evaluate cotangent, just evaluate tangent and then reciprocate. All right. So there's that. Okay. Now let me kind of introduce you then to kind of like the trig evaluation strategy that I kind of like promote. Okay, I will state that some students, they just memorize the unit circle, okay? Again, really the only part of the unit circle you have to have memorized is really that first quadrant, and then you just use transformations to get the other 4, right? So, or the other 3, I should say. So in your mind, you only need to really memorize the first quadrant, and once you have that first quadrant, you can kind of transform it to get the other ones. And then it's, you know, you just go from there. All right, so remember the coordinates and the angles in that first quadrant. That's one option, and students do that, right? Some students, they memorize the whole unit circle and they redraw the whole thing for every like assessment and stuff like that. That could take some time, especially when it comes to, you know, like when you have on, you know, the next 2 days, not tomorrow, but the 2 quizzes after that, it's going to be less than, you know, less than 7 minutes. So you might be a little crunched for time to do that for sure. But like on a big test, that could, you know, work. But this method I'm going to show you, I think, requires you to kind of memorize the least bit okay? Or it's like, I don't know, I feel it's pretty efficient to me, I think. So it does require you to memorize a couple things, though. Okay, one is you have to be able to remember the 30, 60, 90 right triangle, or as I'm going to call it, the pi over 6, pi over 3, 90. Okay, and then you have to memorize the sides that correspond to it. Okay, 1, 2, and root 3. And then you also have to remember the 45, 45, 90, or as I'm going to call it, the pi over 4, 90. And the legs here are 1, 1, and the hypotenuse is root 2. Okay. Now, someone last class asked me, Mr. Widmeyer, when we did these triangles in the unit circle, all of our hypotenuses had a length of 1. Why are you given 2 and then root 2 here? I just do it because it's nicer numbers, okay? This triangle is similar, and I mean similar in the mathematical sense similar, right? They differ by a scale factor. This is similar to the one we used in the unit circle. I just multiplied all the sides by 2. Here, in this one is similar to the one I used in the unit circle, but I just multiply everything by root 2, just so we don't have fractions. They're all nice numbers. Or nicer, I guess I'll say. Okay. Last thing we're going to do here is another little helpful tool. And again, you don't have to write this one down if you don't want to, but it can be helpful. Okay. So this is used to help us remember where the trig functions are positive and where the trig functions are negative. So in the first quadrant, the A stands for all. All the trig functions are positive in the first quadrant. In the second quadrant, it stands for students, right? And we're going to say that sine and its reciprocal, cosecant as well, are positive there. In the third quadrant, T stands for take, right? And we're going to say tangent for that. And then its reciprocal cotangent as well is positive there. And then finally, C, calculus, right? I want to say that's cosine, right? And so the reciprocal cosine is secant, is also positive there. So all students take calculus is one way people remember that. Or ACTS, acts, you know. Yeah, another stupid trig class. Sure, if that's how you remember it. Yeah. Everyone's like, that's the way I'm going to choose to remember it. Okay, however you want to remember it. So these three things will allow us to pretty much evaluate any kind of trig function, okay, evaluate any trig functions we come across that are on the unit circle. Okay, so here's my recommended kind of procedure to follow. One, okay, and it's optional to do this, but I'm going to recommend it just for our purposes. Okay, optional though, convert to radians. Bless you. Okay. 2, identify the reference angle. The reference angle is easier to identify when you are in radians than it is when you're in degrees. You can still do it in degrees, but it's easier when it's in radians. Thank you. Okay. So, what do I mean by a reference angle? Okay, if you look here on our unit circle, all right, we have many angles. But upon closer inspection, these angles and the coordinates that they create, there's not that much difference, right? I mean, we have like, I think 34 different angles that we talk about here, all the way from 0 around to 360 into 2 pi, right? 34 if you include the radians and degrees, you know, it's different, obviously. But the numbers tend to kind of like, you know, you see a lot of repetition, right? We have a root 3 over 2 and a 1/2. There's a root 2 over 2, but there's another root 2 over 2. There's a 1/2, there's a root 3 over 2. And then it's the same numbers here, just some are positive and negative. Same numbers here, just some are positive and negative. Same numbers here, some are just positive and negative. Same thing with the quadrants, too. We have a 1 and a 0, 0 and a 1, negative 1 and 0, 0 and negative 1. Okay? So there's like some repetition here, but how can we kind of organize this? It's organized, or we can organize it using reference angles. So what do I mean by that? Well, let's consider 30 degrees right here, which is also the radian measure pi over 6. Okay? It is 30 degrees off of the x-axis. What other angles are 30 degrees off of the x-axis? Well, 150, right? It's 30 degrees in the opposite direction, back, okay? Or it's pi over 6 back. 210 is also 30 degrees off the x-axis in this direction. And then 330, or 11 pi over 6, is also 30 degrees, or pi over 6, off from the x-axis. And if you look at all of their coordinates, root 3 over 2, root 3 over 2, root 3 over 2, root 3 over 2. And they all have the y coordinates, 1 half, 1 half, 1 half, 1 half. The only difference is that some are positive, some are negative. Okay? Let's look at 45 degrees. Okay? What other angles are 45 degrees, or pi over 4, off of the x-axis? Well, if we go back 45, we're at 135, or 3 pi over 4, and again, it's the root 2 over 2's. If we go 45 degrees, or pi over 4 forwards, we're again at the root 2 over 2's. And if we go 45 degrees, or pi over 4 back from 360, again, we're at the root 2 over 2's there. Okay? Some are positive, some are negative, and that changes. And we'll worry about that sign later. As a GN sign. And then finally 60, right? 60, again, 1 half comma root 3 over 2, back 60 to 120, 1 half and root 3 over 2, forward 60 to 240, 1 half and root 3 over 2, back 60 from 360 to 300, 1 half and root 3 over 2. Okay? So it's a question of, the reference angle is the closest angle that it takes to get to the x-axis. Okay? It's harder to do when you are in degrees. If you are in radians, it's really easy to look at and see. Okay? For example, 11 pi over 6, the reference angle for 11 pi over 6 is pi over 6. The reference angle for 7 pi over 4 is pi over 4. The reference angle for 5 pi over 3, pi over 3. Right? And that holds true for all these. Reference angle here of 4 pi over 3, pi over 3. The reference angle for 5 pi over 4, pi over 4. The reference angle for 7 pi over 6, pi over 6. Okay? You remove the numerator number, and that gives you what the reference angle is. It's super straightforward. Okay? So, let me show you then what we do with that. So let's start off with a problem here, and I'll add the last couple steps here. Well, I'll go ahead and just add the last steps in. Okay, so number 3, evaluate, okay, at the reference angle. Okay, and then number 4, use the quadrant to identify the sine. The SIGN sign, positive or negative. Okay? So it's just 4 easy steps. And these two triangles and this little diagram right here to help you memorize. That's all you need to remember. So it's like 7 things, 7 steps. But it'll get easier again with practice. It'll get easier with practice. So let's try an example of this, what I mean by this. Okay, so sine of 150 degrees. Let's say we want to evaluate this, right? This is a problem that could show up on tomorrow's quiz, for example. Why? Because it's less than 180 and it's sine, right? So we could do this. It could show up on tomorrow's quiz. You don't need to do step, but I'm going to do it, okay? What is this in radians? 5 pi over 6. Okay? Therefore, what is the reference angle? Pi 6, or 30 degrees, right? Either way you want to think about it there. Okay. What is the sine of pi over 6? It is going to be not root 3 over 2. 1 over 2. Okay. Mr. Wade, why did you have us draw these triangles up here? You haven't talked about them yet. Well, here's what I'm going to talk about. Sine of pi over 6. There's pi over 6. Sine is what over what? Opposite over hypotenuse. 1 over 2. Opposite over hypotenuse. Yeah. And then make sure that the angle, yeah, it's the, what is positive or negative, yeah. Tomorrow's, yes, and then for the other ones, you'll have to eat up some of your time to do it, but yes. You can absolutely use them. Yeah. Okay? So, but now that was sine of pi over 6 gives us positive 1/2. We're trying to really evaluate sine of 5 pi over 6. What quadrant is 5 pi over 6 in? Second quadrant. And what do we know about sine in the second quadrant? It's positive, so it's also going to be positive 1/2, and that's our answer. Okay? So we converted to radians. That was optional, okay? Cameron, was it you that said it was going to be 30 degrees? I heard someone over here say it.
Yeah, I did.
It was you, okay? So 150, if you can tell from here that the reference angle is 30 degrees, then you can just do sine of 30 degrees and then, go back like that. But if you convert it to radians, it's easier to see what the reference angle is. All right, let's try another one. Let's do cosine of 240 degrees. Correct. So it won't be on tomorrow's quiz, but it is something we should be able to do anyway. So, okay, cosine 240 is a negative 1/2. All right. Well, let's see here. What's this in radians first of all? 4 pi over 3. That's correct. Okay. So therefore, what's the reference angle here? Pi over 3. Okay. Again, go to our triangle. Our reference triangle is up here. Here's pi over 3. So according to our reference triangle, what is cosine of pi over 3 going to be? What over what? What's the adjacent leg to pi over 3? 1. What's the hypotenuse? 2. So this is equal to 1/2. So this will equal 1/2, but we got to check if it's positive or negative. Where is 4 pi over 3? What quadrant? Third quadrant. Is cosine positive in the third quadrant? Nope. So we got negative 1/2 is our answer there. Okay. See? Cosine 240, negative 1/2. Question, Rebecca, yeah.
This is a dumb question or not, but how do I know which triangle to use?
Well, what angle were we evaluating here? Pi over 3, right? Was a reference angle. Right? So what triangle has pi over 3 in it? There's only one pi over 3 that shows up, so you use that one. Got it?
Dumb question, yeah.
No, not a dumb question. All right, really, there's a lot of it because there's a lot of stuff going on here, lots of ins and outs. Okay, lots of little details to not quite understand. So again, please feel free to ask. Are there any other questions? All right, keep trying some more here then. Tangent 210 degrees. What is 210 in radians? 7 pi over 6. Okay. So what's the reference angle we're going to use? Pi over 6. Okay. Go up to your triangle. Here's pi over 6 on my triangle. Tangent is what over what? Opposite over adjacent. Yeah, opposite over adjacent. 1 over the square root of 3. Okay, so this will also equal 1 over the square root of 3. And again, folks, you don't need to show all this work. I'm showing all this work because it's notes, right? But as you get more practiced with this, you can jump just straight to this part right here if you want to and just say, okay, it's going to be 1 over root 3, and then just figure out the sign. 7 pi over 6 is in what quadrant? Third. Is tangent positive in the third quadrant? Yes, so you can leave it like that, or if you rationalize it, it's root 3 over 3. Okay, that's the idea there. Let's try another one. Secant, 45 degrees. Ooh, secant. Well, if we want to evaluate secant, what other trig ratio are we going to use instead? First. Secant is the reciprocal of, it's 1 over cosine, reciprocal of cosine. Right, so let's find cosine first. What is the cosine of 45 degrees? 1 over root 2. And if you want to look, there's pi over 4 is 45 degrees. So pi over 4 opposite, or sorry, adjacent. Pi over 4, cosine's adjacent. Adjacent 1 over the square root of 2 hypotenuse there. So yeah, 1 over root 2. Okay. Cosine of 45 degrees is in the what quadrant? First, so it's going to be positive. So if cosine of 45 is 1 over root 2, what will secant of 45 be? Reciprocal, root 2 over 1, or just root 2. Okay? Questions? Okay. let's try here. I'll do one more here, yeah. We'll do one more here. Okay, so question, yes, Andrew? Yes, go ahead. Now, the one thing we do have to be careful about is when we don't end up with an angle that's in the quadrant, but like on the border. So what do I mean by that? Well, for example, if we have something like tangent of pi, okay? If I redraw my triangles here, pi does not show up in my reference triangles. Okay? And that's because we didn't evaluate sine, cosine of pi. We didn't evaluate that using reference triangles. Pi, if you remember, is over here. Okay, right, here's pi. Right here is 3 pi over 2. Here's pi over 2. Here's 0 or 360, or sorry, 0 or 2 pi, I guess, if you like. So here's pi right here. Well, let's make this sine of pi over cosine of pi. Okay, let's try it this way. What is the sine of pi? What's the coordinate here at this point? Yeah, the y-coordinate, right, because that's what sine is. Sine is the y-coordinate. The y-coordinate here is 0, so it's 0 over, and what's the x-coordinate here? Close. -1, yep, -1. And so 0 over -1, 0. So tangent of pi, 0. Okay, because of where it is. So the reference triangles and reference angles only help you if your angle's in the quadrant. If it's on the quadrant, like 0, 2 pi, pi over 2, pi or 3 pi over 2, you'll need to just use the fact that the coordinates here are 1, 0, 0, 1, -1, 0, and 0, -1. And then you just sine, cosine, or tangent, go from there kind of thing. It's not too bad, but okay. There's a lot going on, and the best thing I can probably do for you guys is just give you some time to practice this on your own. Okay, so I would highly, highly, highly recommend that you take this next 30 minutes here and work on these problems, okay? So, let me get you guys started on your assignment here, okay? I'm going to give you some work out of the book, all right, to get some practice. Put it up on the board here.
Wait, do we need the books or you just